Welcome to the MSSQL Tips webcast, SQL Server on Linux, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MSSQL Tips and today's webcast host. Our presenter today is Mike Traudt, who's a sales engineer at SIOS. And today he will cover things you should know when running SQL Server on Linux. Before we get started, if you have any questions, you can submit them at any time during the webcast by answering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you're not already a member of the MSSQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Mike, and he can get started.
Okay, thank you, Greg. As Greg mentioned, my name is Michael Traudt with SIOS Technology, and today we're going to go a little sideways and talk about SQL Server in Linux environments. The .next was highly, visible as far as people touching it and playing with it. We have some context around what it brought once it GA'd and some of the things it can't do yet, in addition to methods to protect it and place that in the high availability topologies. Here's our agenda. We'll go through the SQL platform overview. Should be very quick for you folks. Some of the Linux features that came out with the initial release. We'll stop for some poll questions with Greg collecting the poll answers. Talk a little bit about high availability and business continuance in relation to always-on availability groups and their features. And then we have a pre-recorded demo that will walk through configuring high availability solutions with cluster enablement for Linux MSSQL. And then we'll wrap up with some Q&A at the tail end. So feel free to enter questions in the chat and hopefully be active in the poll questions. It'd be very interesting to see what the general audience has to say. So the MSSQL platforms, historically, of course, we've had the Microsoft operating systems traditionally up until the latest and greatest, with always-on availability groups sort of keeping in step and progressing in its own technology for high availability and business continuance. But now Microsoft is embracing this openness, probably, if I dare to guess, from Microsoft Azure, Red Hat Enterprise Linux as a platform, in addition to SUSE Linux Enterprise Server. Ubuntu is also supported, but keep in mind that operating system has no quote-unquote corporation behind it for native support, so that would have to be third-party supported at best. And then Docker, and of course SQL as a service in Azure. Some of the high-level features that the Linux platform has enabled for MSSQL, of course, the core database engine is supported. There's native Linux paths, because as you can imagine, all of the Linux paths to data stores, whether it's NFS or SCSI, etc., they have to be transposed and sort of understood by all the SQL components. IPv6, keeping in step with the current technologies that are out there. The database files can be on NFS shares, which is an option away from a SCSI mount. TLS encryption for security, Active Directory authentication and integration, and availability groups functionality for high availability. There's some caveats to mention there later on in the session. And then full text search, there's SSIS components that are available to install telemetry and full text search. The SQL Server agent with Transact SQL jobs, DB mail and log shipping is also available to install, and the SSIS SQL Server integration services. There are a few interface unique changes in the Linux platform as far as, typically Linux would use conf files and shell scripts and sort of obviously different interfaces than what most would be used to in the Windows platform. Typically speaking, these things are shell scripts and wizards that are text-based, as opposed to GUI in Windows across all of those administrative functions. So there's some other improvements and some notes to be taken. The command line configuration tool is MSSQL-conf, and unattended installation support is available for those that need some level of automation to deploy the solution. There's a cross-platform Visual Studio Code server extension, and that sort of relates to this new thing, cross-platform dynamic management view monitor. And this lets us deploy a SQL solution across both Windows and Linux, and that DMV would sort of tie things together. Slipping into the always-on topics, there's support for always-on availability groups and failover cluster instances, along with log shipping. But that's not to say blindly that it's hand in hand with the Windows release. There are a number of differences, and typically speaking, if they can't support replication level on always on, you don't have HA. At best, you'd have business continuance protection with log shipping and replay. So the HA on Linux, this is a major difference between the Windows platform. Windows is able to embrace the failover cluster manager and the failover clustering services. But on Linux platform, there are many different flavors depending on which OS you have. For the majority of those operating systems, they embrace some core components, RPM packages, YUM available packages from the repositories, which is sort of like a repository to install these sources from. The core of this is Pacemaker. This is the core clustering component. Much like failover clustering services you would install on the Windows OS, Pacemaker on the Linux platforms is sort of the cluster core management component. And other pieces get added to this, like Core Async provides things like the quorum, the witness services, restart failed processes, etc. There's obviously logging that's required. A lot of Linux OSs have sort of log scanning to find out what exactly is going on quickly, and anything that might be posted in those logs would trigger some event alert, SNMP, something to support desk, etc. The resource agent, specific functionality provided so that an application can integrate with a pacemaker. So the resource agent is sort of a listener, an entry point into using the pacemaker feature and function. This allows folks to have add-ons to the core clustering components themselves. And then the fence agent would deal with IO fencing, isolating nodes, deal with failovers, making sure that the consistency is true and tried and true. There are a lot of components here, and typical implementation of these things are not so straightforward. You generally speaking, you need to have somebody that's sort of Linux savvy to confidently install this stuff that's beyond a test bed, right? In production, you would have somebody that knows what they're doing, so to speak, right? Much like in relationship to the more advanced SQL installations on the Windows platform. So Microsoft helps us with Linux command references. This is straight from their website in the Linux install and resource area. The Microsoft website actually does have all of the install docs, all of the install instructions. They have references to install optional components. They also list what it can and can't do in the sense of traditional core services underneath what I've already mentioned. So, but this list is not going to make you a Linux administrator, right? Or make you gain the confidence to the level of implementing an HA solution on the platform. But I found it almost amusing that they listed a dozen or so sort of navigatable terminal commands that allow you to sort of cruise around in a Linux session, but there's a whole lot beyond this, as you can imagine, for those familiar with the Windows layers also, right? So now we get to the exceptional slides. So I mentioned the database engine is supported in the Linux release, and however, there are some sub features that are not ready yet, right? So transactional replication, that's a big one. Merge replication, stretch DB. I'm not going to read the whole slide to you, but the point here is keep an eye out. If you have a consideration that says, hey, maybe some of these components I can use the Linux platform and deploy MSSQL on that. Wait a minute, let me qualify this and make sure that there's no service that's, part of the core business requirements that is needed that it simply does not support yet. And this is scraped right from Microsoft's website. They're pretty much, very open to what doesn't work yet and what is not supported. The SQL Server agent in particular, there's a lot of subsystems that are not there, right? And for a lot of customers or a lot of sites that may be really integrated into what SQL has from Microsoft today, they'll find themselves, looking for alternatives because these features don't exist by design in the initial release of the SQL on Linux. High availability, here's a big one. Database mirroring is not a supported feature yet. So in relation to the always-on availability, that leaves us with log shipping, log replay, etc. Security, key management system is not there in the SQL layers, right? Linked server AD authentication and AD authentication for the availability groups themselves is not there. So in addition, this third-party integration that is common on the Microsoft platform is simply not there for a subset of these things on the Linux platform. So let's shift gears. Those slides were more so to just make you aware that there needs to be careful qualification. Nobody should ever say, hey, I'm just going to use SQL on Linux and everything's going to be fine. It depends on what the business requirements are and what actual available features there are for that platform, as anyone would, best practice do. So we'll shift gears a little bit. So what's the interest in this, right? Obviously, the cloud platforms out there are a big hit. A lot of people are migrating to the cloud, and Microsoft, with the Azure instances out there, they want to look like they're open. And in the back offices, we feel that, they're doing this for that reason. It's all about the cloud. So as a cost comparison, these costs are pulled directly from the AWS site. And this is just representative of a base operating system. This has no SQL licensing involved and no additional licensing stacked on. This is just a base operating system. So when you look at the differentiators between the Windows image and the same types, they're all M3.large, you see a significant cost difference, like 25.9 cents per hour in comparison to the RHEL 7, which does have Core OS support, mind you, at 19.3 cents. That is a huge difference when it comes to price per hour times day, times week, times month, times year, right? So it's a significant thing, and I think this is going to really drive the consideration and probably drive the usage of at least some level of SQL on Linux, right? Especially if SQL has to be the database that's out there. So Ubuntu is, of course, the cheapest, but again, keep in mind, there's no core operating system support offered from the Ubuntu OS. There are third parties that do offer it out there, but you just, it spills over further than that statement, because then you have software that is hesitant to support it. So because there's no operating system support to turn to if they do find an operating system level issue. Right? So on the Azure side, we have Windows at 22.5 cents, and then look, the SLES 12 suddenly becomes as inexpensive as the Ubuntu release, which is surprising to me. But again, the same machine types, the E2, V3s, were all compared. This is just base OS. This is the lowest level I could find on their sites for price quotes. And that is a huge difference, from 22.5 cents down to 13.3. So these cost savings in terms of price per hour in the cloud, I think they're going to cause some obvious interest, at least, in consideration to run on the Linux platforms, as opposed to what we see as expensive, the Windows 2016 platform. So we'll pause here, because I think what would be interesting for everybody is to have some poll questions answered. I see a lot of activity on blogs, etc. A lot of people have comments, a lot of people having install questions and answers, and of course the industry out there is always helpful and really active on those sites. But I gathered a couple questions. I believe Greg will take the poll questions and display some questions and optional answers.
All right, I'm going to launch the first poll here. So the first question is, how many environments do you know of that are at least testing MS-SQL on Linux? I'll give everybody a little bit of time here. And while we're doing this, just remember, if you have any questions about stuff that Mike's talking about or related to moving SQL Server on Linux, feel free to type the questions in. And when we do the Q&A later on in this session, we will take care of all those questions that you've asked. All right, we got a good amount of people responding already. I'll give this another 10 seconds, and I'll close this and share the results. And I'm going to close this and share the results. So we have 62% said none, 38% said 1 to 5, and 0% for the other two options. All right, then Mike, want me to hit the next poll as well?
Yep, sure, we'll just roll through.
Okay, all right, the second poll question. And this question is, how many environments do you know of that have moved MS-SQL on Linux to production? I got a good amount of people voted already. I'll just give this another 10, 15 seconds, and I'll share these results. I'll get those last votes in. All right, let's see these results. So we had said 93% said none at this point, and 7% said 1 to 10, and 0% for 11 to 20, and 0% for more than 20. And our third poll question is, what percentage of your MS-SQL environments do you think can run on Linux? All right, it's good. We're getting some more options on this one. All right, another 10 seconds, I'll show these results. Okay, let's close that and share these. All right, so we have 38% said 1 to 10%, 16%, 11 to 40%, 14%, 41 to 80%, 8% said 81% or more, and 25% said none. So there you go, Mike. Hopefully that can be of use. And
very interesting. Okay, we'll continue on. Thank you for that participation. It's interesting data points as far as who's there, who's not there, testing. Or I was surprised to see the percentage in production, actually. So high availability topologies, we'll touch on this and shift into what is available for HA. As I mentioned before, the always-on availability groups do not support the replication feature. So that brings us into, okay, how do we get a cluster out there to protect SQL? In the traditional cluster, we would need some sort of shared device as a disk. And in the clouds, they simply don't exist, right? In terms of the lower layers of an on-prem solution, yes, they're out there, but it still presents an exception where I have a shared disk, but that presents a single point of failure in that case. You know, not to argue if RAID 6 is protecting that disk, the failure is very low percentage from possibly occurring, but the failover in that case for on-prem could be deployed with shared storage, but in the cloud, it just simply doesn't exist. So how do we get that to be supported in the cloud if there's no replication or shared disk available, right? And that brings us into the SANless clustering topic with the SIOS DataKeeper layer of the solution. I'm sure for those of you that have attended these before with SIOS hosting, you've seen a lot about the DataKeeper product and its integration with Microsoft's Failover Cluster Manager. The same holds true for the Linux. In fact, the Linux was the first operating system that the corporation supported. And in addition to that, they also provided the cluster management layer, which we call LifeKeeper. So LifeKeeper is a new thing for most of you. And the DataKeeper, generally speaking, forms with, comes out with the same feature set that you may have seen on the Windows platform. This enables us to have that replication host-based over a LAN or WAN, and you could set that to synchronous for a core HA pair for a cluster, and then maybe some additional copies out there set to asynchronous mode to be able to afford the latency situations that may come up between regions and between sites. So this failover layer is managed on the Linux platform by our LifeKeeper product. So if you can envision, the LifeKeeper owns all of the other resources beyond replication. And they're tightly integrated, obviously, because they're both developed here with the SIOS Protection Suite solution in SIOS. And that integration is much like you would be familiar with the Windows Failover Cluster Manager and DataKeeper Cluster Edition that we have also in the portfolio. So that LifeKeeper product owns IP addresses, the core cluster features, et cetera, et cetera. The big differentiator here is the fact that this is a one-stop shop for an image install on the Linux platform. And remember a few slides back, we talked about the components that are available to install on those Linux OSs. We don't have to worry about those because the SIOS Protection Suite assembles all of those and does even more interaction and assurance between those components' functionality, that some of which have patent protection under SIOS, and it just makes it a very elegant and simple installation and implementation, which we'll talk about briefly in the slides to come. So getting a little bit complicated in the topologies, maybe you have one-to-many replication. The replication here can go from one to many. I believe the max is 32 nodes if that was a requirement. An enormous amount of I/O. But this replication can have priorities. So if failovers do occur, you don't necessarily just randomly choose the next failover target. There are priorities that are configured in the LifeKeeper layer, and that failover would go from one host. The replication would be aware because of the tight integration at the code level with the DataKeeper layer. If a failover occurred, that replication would be attempted to get back to the host that vacated and also continue the other copies consistently, right? Because the synchronous replication is occurring. So if that failover occurred again, then that replication would follow that application over, and then the failback would be synchronized prior to an actual failback event. So we have multi-site storage and hybrid storage opportunities here also. This could be an on-prem in the left side, where you have the core set of cluster nodes, but perhaps you want a DR copy somewhere else. So in the event both nodes go away in your primary data center, I could have that fail over to the other site and continue that level of protection. And this third site could also be a cloud target. So getting into the Microsoft flavor of cloud providers out there, so you could see we have Azure West is the region, and then different fault domains would be used for the set of cluster nodes and cluster members. And then you'll see this new thing called a Linux witness. So on the Linux platform, we don't have the opportunity to use a file share witness like the Microsoft platform has. That is not a supported thing because the SQL layer on Linux for Microsoft's purpose, they don't understand any of those layers of awareness for the cluster solution. That is all owned by the cluster management solution instead. So with the SIOS Protection Suite, we produce a very lightweight installation to serve as a Linux witness. The only rules are it's the same operating system in the same release versions. So the hybrid, the high availability clusters in the cloud, you know, as opposed to the shared storage, we don't need that. We remove that requirement because we can simply replicate that storage from OS to OS. So that this is a true enabler for the cloud solution across all platforms. The DataKeeper layers, went back. There's a low latency feature here because the block replication is managed by a bitmap file. So we are completely aware of these changed blocks. And these guys are going off the hook here. Hold on, folks. I just need to click slideshow, and then timing's evident. Okay. All right, now we're in control. So there's no configuration limitations in no matter what topology we may have encountered, right? Whether it's physical servers, hybrid cloud, the use of high performance storage, we have integration at that layer that goes far beyond what you would traditionally expect. And that awareness enables us to control things like multipath in physical environments, but the current day, the interest is more so in the cloud solution, right? And not having shared storage available out there is a huge factor. We're going to go AWS as a platform. It's the same rule. They call theirs availability zone 1, et cetera, in the same region type of terminology. All three cloud platforms basically repeat the same type of objects. They change their name slightly, but as you can imagine, the failover feature and functionality would generally be the same. There are some differences in load balancing layers and Route 53 options in AWS, but it's generally the same enabled solution. So the Google Cloud Platform, again, they have zones, West A and West B, etc., within that region. Perhaps they would have, replication across zones, but as you can see, it's the same topology, the same look and feel as far as a topology map would be represented. Now we'll get into a little deeper into the SIOS Protection Suite on Linux. So we talked about the topology at a high level. Now we're going to get into some of the details around what's the SIOS Protection Suite deliver on the Linux platform. And I think it's important in this audience because you're used to maybe seeing the DataKeeper Cluster Edition on Windows, which relies heavily on the Failover Cluster Manager integration. So the largest difference here is the box on the left, this LifeKeeper component. This is the cluster management element in a short description. This high availability failover clustering, it manages the site configurations. It knows what the topology is. It knows how many copies are out there, whether it's synchronous or asynchronous configurations. It owns all of the configuration information. We can leverage any backend in the event you are on-prem and have some flavors and differences at the storage layer. That support goes far and wide there. And it enables us to have automatic or a push button failover. We call it a switchover if it's administratively launched. But that LifeKeeper component essentially replaces in the Windows platform that Failover Cluster Manager. At the lowest level, and folks that have seen these sessions with the DataKeeper Cluster Edition before should be familiar with the SIOS DataKeeper term, and this is host-based block level replication. And being at block level, it's the most efficient layer that we could possibly access in context of protecting two storage elements on multiple hosts. This enables a cluster object to be presented up to LifeKeeper, much like it does for Failover Cluster Manager in Windows, but we remove the need for the shared storage in this way. So, and as mentioned before in the topology diagrams, we have synchronous or asynchronous modes there. In third, which is new for everybody, there's application recovery kits. So what these application recovery kits provide us are prefab integration with any number of applications. It could be SQL, it could be Oracle, it could be SAP. There's some core application recovery kits built into the core installation that manages things like IP addresses and services, etc. Those are some ARCs that are part of the core kit. But the application recovery kits can get much more complicated than that for larger deployments on the Linux platforms. That allows us to connect, a database type with maybe a higher level SAP with all of their components and their services, processes, and virtual IP resources. So these application recovery kits enable this wizard-driven, simple deployment. And that's no exaggeration there. There's very little to do at the command line. The GUI is enabled by these recovery kits, and we'll see that in the demo that's coming up soon. So just getting back to the replication layer for DataKeeper, right? This is as a review. This host-based data replication, leveraging the existing LAN or WAN. There's multi-target options. There's automatic reversal of source and target during failovers. So if a failover does happen, it will try to sync back to its original source in terms of that replication job, right? The block level enables us to remain very efficient, and we monitor this from bitmap files. So a bitmap file would track which blocks need to be updated to all of the targets involved. And if we find dirty blocks, then we know we need to send data to that to get it in sync. But this prevents full resyncs for things like, patch management. If I wanted to go apply service packs to each of my hosts, or I wanted to go out and, test failovers for business functions, sort of a proof positive that we're ready for a failover if it does happen, this bitmap file removes the risk of needing to do a full resync. And in very large environments, a full resync could take many hours to get that HA partner back in sync with the data. And the recovery kits, as I mentioned before, they really are the connective tissue for all these other things, right? DataKeeper handles its job of synchronizing data. But now, how about all the services that are involved in the application stack? How about the applications themselves? Any databases that need to be related in hierarchies and dependencies? How does this happen, right? So these application recovery kits are the true enablers to that. And when they're installed, it just makes it an elegant solution to the point of enabling this easy-to-use wizard to complete what's traditionally a very complicated deployment in HA. So the recovery kit architecture, generally speaking, the database application recovery architecture is the one of the highest interest because usually that involves some DataKeeper resources. It involves mount points and devices that are presented to the operating system. We can have primary database server process protected, and optionally, we can have those server processes shared across the nodes. So if I had two nodes, host A and host B, I could have multiple instances protected on each node individually. So if I had instance A and B to protect, I wouldn't necessarily have to have them all active on host A. I could have host A normally serve up production for instance A. And then on host B, I could have instance B normally be served for production off of that host. This enables us to spread the compute power across the resources. And in terms of the cloud deployments, it's a very critical path as far as costs goes. But each of these nodes protect each other's resources at the same time and offer a failover target for each other. So we call that an active-active situation. And then the other SPS application recovery kits are available for the other layers of things beyond application or database specifics, such as virtual IP resources. Obviously, if a failover occurs, we need to redirect that IP connectivity to the surviving host or the target host that was failed over to. These database configurations, as I mentioned, as opposed to the active standby, we don't see a lot of in deployments today. We do see a lot of the active. Just keep in mind when these are being architected, we want to sort of segregate the stack all the way down to the presented LUN or disk device, because if a failover needs to happen and that device is hosting a lot of other things, all of those things have to be failed over with it, which include all dependencies above the solution stack, right? Storage configurations can be anything, replicated storage, network attached storage, fiber or other for on-prem stuff, but typically the EBS volumes, you want static volumes, obviously, in cloud deployments, but that's a best practice and documented very clearly. The switchover or failover considerations are handled by the core code of the LifeKeeper solution, right? But this enables me to make it consistent across many, many different flavors of Linux if I had them. I don't have to retrain specifically on a Red Hat, and then a SUSE is different, and et cetera. The list goes on. But the maintenance operations gain a huge amount of efficiency because of this, and it just gives an administrator a little bit more confidence and assurance knowing that since 1999, the solution's been out there in production functioning. So it's just simple and easy to deploy and use. This is your first hint into the user interface. In this case, I have an active host and then a standby host. This is not an active configuration. It could be, because you could see from the hierarchies in the image that these are not necessarily all connected to every other resource. So some of these could be hosted in other hosts, but that all depends on the dependencies that are configured. In the Linux world, that you would install an X11 Linux application server, right? There's a component for X11. It's sort of like an RDP server, but it just enables GUI redirection for X11 type of connectivity. So as opposed to using Microsoft RDP remotely, you would use an X11 redirect via PuTTY as an example, and that would give you access to the Linux GUI. So we're going to run through a basic MSSQL on Linux demo. I'll walk through a little summary of properties, of elements we touched on and spoke about in the slides, and hopefully this sort of gives you a third round at what we've just discussed in terms of the components in building the hierarchies and dependencies. So first off, let's talk about the topology we're dealing with here. And that topology being a Red Hat instance, SQL 1 and SQL 2 hosts that are out there. I don't have a witness because I just wanted to make this as simple as possible. In addition, this specific environment is running off of my MacBook. So the instances here, we're going to take a look at some of the topology elements, and you notice that they're all stacked up. We'll take a look at the DataKeeper layer first. We'll open the properties for that. This provides us with instant view of the replication status. As you can see, the SQL 2 is actually hosting the active things. And under the General tab, I can have intelligent switchback or automatic switchback if I wanted to fail back to the highest priority. You notice the equivalencies here. These are protected between these two hosts. If I had more, you would see more hosts here. And the hierarchy and dependencies, I have a parent that is the mount point and the root of the SQL application itself. Now we'll go into the SQL app layer and open up some of those properties. And the SQL app is actually a generic application that uses scripts that are fed into the solution that handle restore, remove, recover scripts, start and stop the services in the event of failover, and the same type of equivalencies would be presented here. We don't have to configure these. The configuration is sort of more automated. I can see I have two children relationships to the SQL app itself, the virtual IP, and of course the mount point for the data, right? And speaking of that, we'll go into the IP layer now on the active node, and this is the virtual IP. And as I mentioned before, these arcs are unique per data type, right? So now I see IP configuration far different than the other resources we saw, but it monitors things like ping lists to make sure things are alive and confirming that it's there. The same general features in the General tab, and the equivalencies, of course, who else owns it. The root of this is the SQL application itself, and that is also the parent because that's a virtual IP for the whole application access. Now we're going to go and actually get a mirror status brought up here in preparation to see the failover in action. But as you can see on that left side, we have all these resources. There's IPs, there's data as far as drives go, there are mount points, and then finally there's the SQL system itself, right? So these are the pointers to what's in the scripts. In this example, I have restart and stop and start for the SQL Server processes. As you can imagine, I need to be aware of what's starting and stopping if I'm going to fail over the database instance. I'll just drag this down a bit to monitor the configuration of the data layer while this failover happens. We're going to see a lot of things going on in the failover. This just proves this thing has been around since 1999, and all of these back-end things are going to happen by a couple clicks, just by bringing SQL 1 application in service. It's going to take all of these offline on the source, which is SQL 2 currently. It'll restore those in context of their hierarchy and dependencies. You see at the bottom that one dirty, that shows that we're flipping over the data synchronization from the host to the other node. And in doing so, it's going to be out of service temporarily. But now we check the bitmap. Remember that bitmap tracks all the changes? And once that bitmap is checked, it's going to bring up the synchronization in the opposite direction, and everything will be happy because that is the lowest child. We're now back in business. Everything will be green in the back end, and the synchronization will continue to get to the point of 0 dirty, and we're up and running again. So that failover was very fast. Now I'm back to my preferred host, and I set these to manual failbacks. So that's why we waited in the demo to just hold out and wait for that failover command to occur. Action-packed. So as we wrap up here, this SIOS Protection Suite summary, right? This is designed for Linux and all of the platforms that we support. It's a best-in-class solution for high availability. Includes the data replication layers and the disaster recovery options, and it's scalable to meet the business needs in ways that, you know, I could have on-prem, cloud, hybrid solutions, what have you. These core elements in that enablement with all of the application-aware agents or application recovery kits, as we call them, tie in the applications, the databases, the services, processes, and IP resources all together to enable an easy-to-use wizard-driven UI for not only the configuration of implementation, but also the ongoing management in terms of feature and function that an administrator would do, you know, post-implementation. So this architectural consistency across of the Linux platform is very well received because it avoids some unique training requirement for every one of those platforms, right? And it's been tried and true and proven for 10 plus years. So with that said, that is the summary of this session, and I believe Greg will open it up to some Q&A we might be able to answer.
Okay. Yep, there's some questions, and while we're doing the questions, I'm just going to pop up another poll, and people can answer that as we're going through the questions. So the first question, Mike, is, while doing maintenance, can I stop the DataKeeper replication, and when I start it again, will it recognize all the change blocks?
Yes, it would. Any changes while a copy is offline is marked and tracked by that bitmap file. So nothing will happen until that bitmap is converged to 0 dirty blocks. Sort of like the way any of the deduplication products would work in their replication rules too. The metadata must match the actual data before it would let anything happen.
Okay, another question we have is is it possible to cluster between a Windows and a Linux server?
Not with the SIOS Protection Suite. I know I saw a video a month ago or so where they migrated from Windows to Linux with some Microsoft development guys, but we don't support cross OS platform replication today.
Okay, another question somebody has is, can you run in an active-active clustering situation?
So we can run an active-active per instance. So it would have to be DB instance unique on each node, and that could be active-active. We do not support topology where I have the same instance on multiple nodes concurrently, like a grid computing, so to speak. But the most common is segregating those instances so they're unique instances on multiple hosts, which enable that scale-out thought to actually come to fruition.
Okay. The next question is just related to the replication with DataKeeper. Is it possible to replicate other files besides SQL Server files, or can you kind of talk about that a little bit?
Yes, and I sort of left that out to try to stick to Linux, but yes, the DataKeeper layer, or any service, or any IP resource, or any of the pieces that are supported in the SIOS Protection Suite, you can protect any single element or any combination of those elements in any way you'd like. So we could do a file system by itself. We could do a data volume by itself. We could do a service by itself. A lot of customers have these very complex builds where they're only interested in that service, and they want to use our solution to fill it over because it's the one-stop shop. So it's a very common use.
All right, let's see. Another question someone has is, have you worked with any customers that have actually running SQL Server in production on Linux? And can you just kind of talk about that situation?
We have not in production yet. It's been talked about, it's been asked, but nothing in production. Maybe an eval or two at best so far, but obviously from the poll questions and answers we've gathered, it will be coming. It's just a question of maybe they're not aware of the solution, but we expect it to be ramping up, obviously.
All right, another question is just related to the use of the cloud. Somebody's just wondering, do you think people will be using the cloud more for Linux implementations versus doing things on premises?
Yeah, I think it's a business decision that's beyond the HA. In our interactions, we are sort of the one-stop enabler to not be restricted from going to the cloud and maintaining cluster protection. But obviously, on-prem or cloud, we don't really care because the solution works the same way no matter what platform we're on, right?
Okay. Another question is related to the versions of SQL that this works with, both for, I guess, for Windows and for Linux. Can you just talk about that real quick?
Yeah, so the Linux specifics are posted on the Microsoft website. I don't recall the exact versions, but the SQL Server version is the v.next. I believe they call it SQL Server 17 in this case. Maybe Mr. Birmingham recalls the exact version.
Yeah, I think actually they were talking about the DataKeeper solution. I'm sorry about that.
Yes. So for the DataKeeper solution, the latest SIOS Protection Suite is version 9.2.1, I believe. And for this solution, it is almost generic to us, right? Because it's the same volumes that we would be presented with any type of integrated application. And in this case, we're just taking processes and virtual IP resources, and we are making them alive on whatever host we want them. This actual implementation is done via a generic application feature that the product has. So even if you had a homegrown application, the SIOS Protection Suite on Linux could possibly protect that in a cluster layer, as long as there's some level of checking the status of services that are involved with that topology.
All right. Well, that's all the questions. I don't think anything else you want to add, Mike, before we wrap things up.
No, I mean, I'd be real interested. I mean, we're always open to hop on calls or, get some knowledge transfer happening. So, we're always here, always available. And any questions that come up, feel free to share our contact info. We can hop on a WebEx, and especially if you have customers that you think could heavily benefit from the solution, and they're talking about the cloud, but these exceptions come up in those meetings. That's where sort of we shine. We gain that confidence in that decision, and it allows major projects to continue onward and upward based on what the business targets are. Right? We're always here.
All right, great. Thanks. We're going to wrap things up. So thanks, Mike, for sharing that information today, and I also want to thank SIOS for sponsoring today's event. The webcast is recorded, and you'll receive a follow-up email with links to view the archive. It will also post a copy of the slides you can download as well. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux for MS SQL Tips. Thank you for attending, and have a great day.
Thank you.